Chapter 2, Kinematics. So distance is the total length covered by a moving object regardless of its direction of motion. The SI unit is in meter. It is a scalar quantity, means it has magnitude but no direction. For displacement, is the distance measured in a straight line in a specific direction. So it's like the shortest straight line from point A to point B. The SI unit is in meters. It is a vector quantity because it has magnitude and direction. Okay, let's look at the distance traveled from A to B. So you can go on a path of 10 km or even a path of 7 km. Those are distance. So the total distance will be 10 plus 7, 17 km. But for displacement, is the shortest path between 2 points. So it's only 5 km from A to B. However, if it returns from B back to A, the total displacement is 0 km. Let's try one question. The rat moved through the tunnel to reach the cheese. So the distance the rat traveled was this path, which was 3.5 meters. However, the displacement from the rat's initial position to the cheese is the shortest distance, 1.8 meters. Speed, velocity, and acceleration. So here is a diagram showing a cyclist going from point P to point Q. So he goes through a distance of 300 meters, whereas his displacement, the straight line path from P to Q, is 168 meters. He took a total of 120 seconds. So let's look at the speed. So speed is the distance moved per unit time. SI unit is meters per second. Speed is a scalar quantity because it has no direction. The formula is given by distance over time. So for the cyclist speed, we'll take 300 divided by 120 to get 2.5 meters per second. Velocity is the rate of change of displacement. Same SI units, meters per second. It is a vector quantity because displacement has direction. So velocity equals to displacement over time. This time round is 168 divided by 120 seconds. You get 1.4 meters per second. Okay, so what is the formula for average speed? Average speed is equal to total distance over total time taken. This total time taken also includes any wait or stop time. Average velocity is just total displacement instead of distance over time. Let's look at one of the questions. The following diagram illustrates the journey of a skater or a skier. The skier moves from A to B to C, then to D. What is his average speed? So for speed, it's total distance over total time taken. From A to B, he goes back to C, and then he goes to D. This is the total distance. And this total distance is given by 40 plus 100 plus 40. Okay, so that is from A to B, plus from B to C, it's 100 plus 40. For C to D is another 100. And the total time taken, it was 3 times 60 seconds. You need to convert the minutes to seconds, and you get 2.3 meter per second. Whereas for average velocity, we look at the total displacement. So the total displacement from A to D, it's only 40 plus 100 divided by 3 minutes, which will give you 0.78 meter per second. Acceleration. So acceleration is the rate of change of velocity. The formula is given by A equals to V, final velocity, minus initial velocity U over time. The SI unit is meter per second per second. So how do we describe acceleration? Okay, when an object is in constant velocity, its acceleration is 0. So if the object is not moving or at rest or stationary, its acceleration is also 0. So a car travels at constant velocity, the acceleration is 0. The truck remains stationary at a junction, the acceleration is 0. There's two types of acceleration. One is positive and one is negative. For positive acceleration, the velocity increases. In other words, the object is speeding up. So a motorbike changes its velocity from 0 to 90. So 0 is initial, 90 is V in 5.0 seconds t. What is its acceleration? A equals to V minus U over t, which is equals to 90 minus 0 over 5.0, which will give you an acceleration of 18 meters per second per second. Okay, now let's look at negative acceleration, which means the object is actually slowing down. Okay, or it could be traveling in the opposite direction. So negative acceleration, we also call it deceleration. So let's look at the toy who slows down from a velocity of initial u to a velocity of 10 meter per second v in time t. What is its acceleration? A equals to v minus u over t equals to 10 minus 25 over 3.5, which will give us a acceleration of minus 5.0 meter per second per second. Okay, so what is its deceleration? Its deceleration is equals to minus A, which is 5.0 meter per second per second. So we have been talking about constant acceleration or deceleration. There's also forms of non-uniform acceleration and deceleration, which could be increasing, decreasing, or increasing deceleration, decreasing deceleration. Okay, let's look at some distance time graph. So we have a distance time graph here. If the line is here, means there's no change in distance, it's at 0 speed. If you see that the distance is changing linearly, it is constant positive speed. If it's curved upwards this way, it's increasing speed. Curve this way is decreasing speed. Okay, so the gradient of a distance time graph will give you the speed. Then next we upgrade to the speed time graph. Same thing, a straight line here means v is 0 meter per second, means the object is at rest. If v is a constant number, non-changing, means it's at constant speed. If it's increasing linearly, means it's constant acceleration. If it's coming down this way, it's constant deceleration. Minus A. And there's also a graph showing decelerating acceleration, increasing acceleration, decreasing deceleration, which is slowing down, or increasing deceleration. So the gradient of a speed time graph gives you the acceleration of the object. Next, the area under the speed time graph will give you the distance traveled by the object. So now you have a speed time graph here. If I want to find the distance traveled in the first 10 seconds, I just need to find the area under the graph here, which will give me the answer. For B, I just need to calculate the rectangle. For C, okay, you need to be careful for C. You need to calculate this triangle as well as this rectangle. For D, it will be the same thing, just a triangle. Acceleration of free fall is actually due to gravity. The acceleration of free fall for a body next to Earth is constant and is given 10 meter per second per second. So an object falls without air resistance only happens in vacuum. Okay, means because there's no air, there's nothing to resist the motion. The only force is its weight. So if I were to draw the free body diagram, center of gravity, the only force acting on it is its weight, and it's downwards towards the Earth. Okay, so the object experiences a constant increase in velocity. How fast? G or A is equal to G 10 meter per second per second. Okay, G is constant and acceleration is not dependent on the mass or the size on an object. So a big object or a smaller object okay, the acceleration is the same. Okay, but the force it experiences is different because the force is given as W equals to mg. Next, object falling with air resistance. Okay, air resistance is a frictional contact force. It's due to the object moving through the atmosphere or moving through air, and it always opposes the moving object. So friction opposes motion. This air resistance increases with the speed of the object, surface area, or the density of air. Okay, and that's the end.